Welcome back to Hayes' World of Math. We're going to talk about how to write equations with polynomials today. But of course, I would not be on YouTube if I didn't say make sure you like, subscribe, and comment. So I'm going to show you an example, much like I did with synthetic division. I'm going to show you an example first, and then we'll talk through exactly what happened there next. So in this case here, polynomial least degree. Now, if you remember right, when I'm writing a polynomial, if I write it in factored form, I can figure out what's going on. So like here I have 1, 2, 3 zeros. And those zeros, x-intercepts, roots, however you want to call them, are found, and you can write it in factored form by changing the sign, remember, right? So I've got that. That's supposed to be 2, not -2. My marker slipped just a touch. So when I'm setting that up, I'm going to have, if I'm just these in order as they are over there, I would get that. Now, before we do anything else, a couple of other things. You kind of have to see, okay, end behavior. I'm going up here at the end, which means that the leading coefficient is going to be positive. Since the front end is matching the back end, that means it's going to have an even degree. So that means I have 4 different roots going on. So even though I have 3 zeros, something has to be happening more than once. And that is going to be, if you notice, and this is what we talked about here, is that something's different is going on at 2. Now, one thing that I tell my students is this. If I look here, if you look just isolated at the you can kind of get a sense of what's going on. If I zoom in just here at the -3, it looks like a line. This is going straight through. You don't near -3. -3 has the most influence. So that 0 happens once. If I come back over here, notice what's going on at 2. It's bouncing. It's looking like a parabola, so it's going to act like that means there's 2 zeros there. And then likewise over here, there is a bit of a curve, but it's not doing anything drastic there. So that's going to happen once. So we actually over here have then that. Okay. Now the only other thing that happens is this. There is an infinite number of polynomials that would have this same set of zeros. So one could be like this. I could have it have a -1, and it could look like that. It could be really, really low key like this. And they all would have the same general factored form of what was going on, okay? So because of that, we need to kind of have something that locks it in. Now remember, an equation is the roadmap for all points that are exactly on that line. So we need to find a point that's going to lock that in for x and y. Now this a out front here is going to play the role of what does the locking. And so we need to find a point that's nice. This point right over here is going to work. Most of the time, at least in my classes, I do give specific points. I'm not sure why I didn't this time. So you're going to plug in the -24 is my function value when x is equal to 0. So I'm going to plug in 0 everywhere I see an x. And then I'm going to solve for the missing variable that I don't have, the a. So in this case here, I have a -24. A 3 times 4 times -4. So that is going to be a -24 is equal to -48a. So then a is going to equal 1/2. So then my final equation would be is equal to 1/2 of x plus 3 times the quantity x minus 2 squared times the quantity of x minus 4. And there we have an equation that locks it. Okay? Now, oops, moved too fast. So again, let's talk about what we did here in terms of steps. Okay? So step number 1, okay? We looked at general end behavior, so we can kind of have an idea of what to expect. That's a little small. My apologies. Then from there, we use their arrows the basic factored form. And then lastly, we use a point on the line, and it can be any point. Okay. Except for actually it can't be x-intercepts. But you're going to use a point to find leading coefficient. And then from there, away you go. Now again, please pause where you need to, and we'll go from there. Now one thing which I didn't address, which I meant to, but I'll do it now, is this. It says, what does this mean of a polynomial of least degree? And what that means is that, for example, when I look at this section of the graph, it looks like it's second degree because it's kind of like a parabola, but how do we know? And so let me show you what this will look like if it's other things. So here's a graph. You can see the equations here. Okay. And the equations are the same except for the fact that the 0 at 3 happens more and more times. Notice what's going on in the graph down here. I'll zoom in here so it's a little bit easier to see. But notice here the red line is the one where it's x minus 3 squared. The blue is where x minus 3 is to the 4th power, and the green is x minus 3 to the 6th power. Now notice how it gets flatter the more that we get, the higher the exponent is. Okay, and that's because as you have, like here, if I took 1/2 and I raised it, squared it, that would take it to the 1/4 power. If I take 1/2 and raise it to the 4th power, now I'm down to the 1/16 power. If I take 1/2 away from that 0 and I raise it to the 8th power, now I'm 1 over 256. So that y value is getting smaller and smaller and smaller and smaller faster. And so because of that, there is no, I mean, you can kind of guess what the least degree is going to be, but if you see this bounce going on here, or if it's cubic, the twist that's going on there, there's no for sure way of saying, okay, is that a square or a 4th or a 6th or an 8th in this case. And so they say of least degree, so then you're going to use the smallest degree. So in this case, you're going to say it's going to be squared, unless you have other information on that. So finding the equation of the polynomial of least degree with this graph. So here are some examples. So let's go through the steps. First of all, I know it's going to be cubic because I've got 1, 2, 3 zeros, and it's got 3 changes of direction, but I've got 1, 2, 3 zeros. None of them repeat, so that's nice. It ends going up and it starts going down, so that also says that we've got 3. So our a value should end up being positive. My base form, I'm going to leave an a in there. I've got x plus 4 from the negative 4 y-intercept, x plus 3, and then x minus 2. Now from there, you can use any point, again, except for x-intercepts. I'm given this point 0, negative 6. This is going to be find a. And again, there's some ways that you can kind of finesse this. I'm just going to give you guys the basics here. And once you get used to it, you can probably find a few shortcuts on your own. So in this case here, that's going to be negative 6 is going to equal, when I multiply all of that out, that's so a is going to equal 1/4. Now, a couple of little mistakes that people tend to make. Some people get really excited right here, and they know that 6 times 4 is 24, and they end up making a equal 4. So be careful when you're solving. Go slow enough that you don't make that mistake. And then here, your final answer. Now, listen to whatever your teacher says. I tend to not have students multiply this out for the fact that I've already tested that earlier in the year. And if I'm trying to know if they know how to write equations, having them multiply this out is not necessarily going to be helpful because I've already know how to do it. Now, if you want to do that, I would say give the majority of points of getting it here in factored form and then just do a little bit of an extra for the last of it, but that's my own personal opinion. Okay, last example since I'm just at that 10-minute mark. So this one's the same idea. Now notice here it is going to be, again, an odd number. So I'm starting down, I'm ending up, so that's different. Now I've got 2 zeros here. I've got one there, and I've got one here. So that's 2. So something's going on here. So we're going to have something to a degree. I'm going to use g of x just because it's something different. I don't know what my a value is. Now that first 0 is happening at -1. So I'm going to do that. Now notice here, if I zoom in on that section, it looks like a cubic equation. So because of that, I'm going to write that as cubic. The same one over here at x equals 3 is a bounce. So for least degree, that we're going to count that as a 2. Or happening twice, multiplicity of 2, so I'm going to do that. So that's the base equation. And then from there, we need another point. So I've got my other point here. So I'm going to plug that in. 1 is my x output value. A, we don't know yet. And again, I'm assuming a lot of my students will end up eventually. Oops, that should be a 3. Yeah, Mr. Razor, waiting for you to make a mistake. Yeah, well, congratulations. But what ends up happening, a lot of people go ahead and instead of writing 2 plus 1, they'll just change it to 3, and we'll change this to -1 right away. It's obvious the math is not extremely hard. That's going to be 3 cubed times -1 squared. So that's going to be 27a. So a is going to equal 127. Now, the higher degree you have, the more extreme the relative minimum and maximums are going to be, which is part of the reason why you end up having these fractions. You got to scale it way back because you're dealing with this case having to scale back off of a degree 5 equation. So you got to be careful of that. Okay, so don't be surprised if you get some really kind of interesting fractions there. So anyway, I hope that helps. There's a bunch of videos listed, and I think I have them all in a playlist now. So obviously take a look from there. I've got a couple of other videos linked here at the ending screen. So if you have a second, feel free to check those out as you need to. Feel free to comment down below if there's anything that's unclear. And make sure you subscribe, obviously. And we will see you next time.